In this video, we'll go through the process of assigning 3D models into EDM Library Cockpit. There are two main methodologies of assigning 3D models. If you have a large mechanical database with many 3D models, you can bulk import and assign them to the electrical part number or cell name via a mapping file. We also allow you to import a 3D model individually to that component or cell name directly in EDM Library Cockpit. We will first start off with bulk importing several 3D models directly into EDM Library Cockpit. This can be done through the bulk import command. We simply browse to a folder where 3D models reside, and EDM Library Cockpit will review and assign those 3D models directly into the database. We can now review the 3D model. You can select the Library tab, see the 3D model section, and we'll search for a connector. In the 3D model, you can see that we have the name, the partition that it's placed in, as well as a 3D PDF to validate the 3D model. In the 3D PDF, you can review, validate, rotate the 3D model to see if it matches your mechanical library. Now that we have the 3D models imported, we can now assign them to our part or cell in our central library. This is done through the mapping file. This can be accessed through the 3D models import mapping file option. To use this command, we have a pre-configured mapping file which associates the part numbers to the 3D model. This will also bring in an alignment file that we have created prior to this import. If you don't want to use the alignment file and want to use the absolute coordinate system of the 3D model, you can use the model's origin command. We will alias these 3D models to the components using the import mapping file command. The import is finished, and we're ready to review the 3D model assignment. To see the assigned 3D model, we will go into the Components tab and search for one of the 3D models that we have mapped to our component. We can do this by selecting the object and opening the 3D Model Manager. In the Model Manager, you can see that we have assigned the model directly to the component in EDM Library. We can modify the assignment and see that there's manual alignment of the 3D model, and we can review it in Cell Editor. In Cell Editor, you can see the 3D model imported and aligned with our 2D cell. Next, we'll start some individual assignment. In this example, we have a 28-pin SOIC. We'll go into the 3D Model Manager. In 3D Model Manager, you can see that there's no 3D model assigned. In the Modify dialog, we can use the Find 3D Models to search a parametric database that we have built with our starter library to query data that's associated to your 2D cell. In this case, we're looking for a 28-pin SOIC. The pitch is 0.065, and the component width is 6.4, and the length is 9.7 millimeters. As you can see, as I was entering criteria, it was automatically filtering the 3D models for associated components. In this case, it doesn't have a test point, so we just want the SOIC added to the design, which we can do through the Assign button. We can actually preview the data using the preview icon. You can review the 3D model in the 3D PDF, and you can even open Cell Editor. In this case, this is satisfactory, so we're just going to assign this 3D model and commit our assignments. The last assignment we will do is through the step import or a third-party file format. In this example, we downloaded the step file directly from the manufacturer for a connector. We'll go back into the 3D Model Manager. We'll modify the assignment. Press the Import button to open up Cell Editor. In Cell Editor, we can select the part number and Import button to browse for our 3D model. As you can see, we support SAT, IGES, and native NX part files directly in Cell Editor. We'll select our connector that we downloaded from the manufacturer and press the Import button. In this example, you can see that in this 3D model, the absolute coordinate system, the orientation and location is different than the one that is expected in Expedition. In this case, we have our rotation markers to quickly align the 3D model. To see that it's placed in the correct orientation, we can turn that off and align the pin pad center with the 3D model and the 2D cell. We can also define the seating plane of where this 3D model will be sitting, most likely on the component pin pad. And you can see that we can quickly align and bring that 3D model directly into Expedition. Now that we're finished, we can close Cell Editor, save our changes, see that the model is assigned, and then commit our 3D model assignment. We have now bulk assigned and individually assigned 3D models so that you're ready to start your own 3D model assignment in your central library.